By the way, in the previous video, I'd like you to finish activity 11K and this will be checked on Wednesday. Okay, let's now proceed to the second lesson, which is our focus this coming Monday, tomorrow. So we'll now go into differential equations. To put it simply, if you talk about differential equations, it will just be an equation that contains derivatives. Just like when you talk about linear equations, these are equations that contains linear expressions or mainly linear expressions, similar for quadratic equations, logarithmic equations, and the like. There will always be a touch of the given concept or topic. In this case, derivatives. All right. So let's have an example here. Find the solution of the differential equation given this function and also given that at y sub 0, the value is equal to 4 or the function is equal to 4. Pause this video, read, and understand. All right. So if you recall, for this particular given, what makes this quite complicated, it's because we have a y and then we have a dy over dx. Now, we can only do integration if we have a function, say x, with respect to dx. Or with respect to x, not with dx, with respect to x. Or we have a function y with respect to y as well. We cannot integrate an x with respect to dy, nor we can integrate a y with respect to dx. Integrating a function of x should be with respect to dx, or with respect to x. Integrating a function of y should be with respect to y as well. So for the first one, we can now say it's x squared over 2 plus c, and it's y squared over 2 plus c. Now, in this case, all we have to do, whenever you do differential equations, all you need to do is to algebraically manipulate it such that the y function should be with respect to y and the x function should be with respect to x. So for the given, we can manipulate this one, okay, by doing cross multiplication with the dy over dx. So we can just cross multiply dx to the other side. Thus we get y dy is equal to the function x squared plus 1 dx. So in this case, it's now appropriate. So we can now proceed at integrating it in order for us to find a solution to this differential equation. So we integrate both sides because they are now appropriate. The y is now with the dy, the x function is now with the dx. If we try to integrate this, thus we will get this. So we have y squared over 2 is equal to x cubed over 3 plus x plus c. Pause this video and try to understand. Most importantly, don't forget to take down notes. All right. Now, for us to find a solution, of course, we need a value of y and x at a certain time. So we are given here that y is equal to 4 when x is equal to 0. Okay. So we can just simply substitute it in order to find a specific value of c. So we have 1/2 4 squared is equal to 1/3 0 cubed plus 0 plus c. And so if you try to simplify it, c is just equal to 8. Therefore, our solution to this differential equation, or this differential equation, will just be equal to half of y squared equal to 1/3 x cubed plus x plus 8. And this is how to solve or to find solutions to your differential equation. Pause this video, understand, study, and take down notes. Let's have another example. Let's say this is the one that we are going to do. Pause and try to study first. Okay, so again, we just do manipulation, algebraic manipulation. We can cross multiply dx to the other side, but then we have a y here, so we have to divide both sides by y so that we can have this particular expression or function. Okay, so just to manipulate it further, we can write it as 1 over y dy is equal to 6x squared dx. So this is by algebraic manipulation. We are not doing any integration yet. As soon as we arrive at this form wherein they're now appropriate, the y function is now with dy and the x function is now with dx, then we can proceed at getting their integral like this. All right. So when we get their integral, we now have ln y equal to 2x cubed plus c. Remember your integration rules. All right. Now, here we are given that y is equal to 2 and x equal to 0. However, before we do substitute, we need to simplify this first. Else, this will be quite difficult for us. So I'd like you to recall how to simplify or what are the different properties of your logarithm. So that it's very, very important. So I won't review them, all of them, but I will just review what's essential for a certain topic. So it's your job to review your previous topics or notes. May it be in grade 11, grade 10, or even previous than that. Now remember that to solve a logarithmic function, we just have, or to solve a natural logarithm, we just have to raise it to the power of e. Basically because your natural logarithm is with the base e. All right, so there is a certain property of natural logarithm that if you are to raise your ln function, or say lny with, if you are to raise your e with the function ln of y, this will just be equal to y itself. So review on that property of logarithm. So if we are to do what, actually the thing here is, we are going to simplify the left portion. This is our basis here. Whatever we do with this, we just have to apply it to the one at the right. So for us to solve for the y, we have to raise this function to e. Again, that's a property of logarithm. Since this is base e, raising this to, e raised to this particular power would now leave us with y. And since we did this to the left, we also have to do that, to do the same thing at the right. So e raised to the function we have at the right. Thus, we have y equal to 2x cubed plus c. Now, remember your laws of exponents. If you have e power of 2x cubed plus c, this is product rule. This is because we are multiplying we are multiplying two expressions with the same basis. So we can separate them actually. Again, this is reverse product rule. So thus we can have this. And take note that e to the power of c will just be a constant. E is a constant raised to another constant. That will just be a constant. To make it less complicated, let's try to equate it with one value. Let's say g. In your book is using a, but I'm using g now to highlight that this is just a constant. I can use any variable for this, not necessarily a, b, c, or d. It could be any. In this case, I'm using g. Therefore, I can now simplify the given function as y equal to g times e raised to the power of 2x cubed. Now, at this point, since it's now being simplified, we can now further find the value of g. All right. And that is when we put in y equal to 2 and x equal to 0. So if we try to do a little bit of manipulation here, g will just be equal to y over e raised to 2x cubed. Putting the values of y and x, then we got g equal to 2. Therefore, the solution to this function will just be y equal to 2 times e raised to the power of 2x cubed. I know this is quite difficult, that's why I'd like you to study in advance. Okay, pause this video and then copy down notes and study, please. This will now be the last example. By the way, this may look complicated at the beginning, but towards the end, perhaps it will become familiar, hopefully. So let's have another example. The rate of growth of mold on large petri dish and so on. Pause this video and read by your own. All right. So if you try to look at this, the word directly proportional gives a somewhat an equation already, a relationship already, but we just have to identify the quantities that are directly proportional to each other. In this case, we're given that the rate of growth is directly proportional to the amount. So the rate of growth, that means growth of a certain mold. So the growth of the mold is actually quantified by means of the area it covers. Therefore, the rate of growth is with respect to time. So your rate of growth here is dA over dt. This is just the slope, in other words, how mold changes over time with respect to time, how the area of the mold changes with respect to time or each time, and of course the amount A. So from here alone, we can now create an equation d of A over d of t, which is the first quantity, that the dependent quantity is equal to the constant k times A. Again, this is direct proportional relationship. That's why we have this particular equation. So I cannot review this one already. Recall your notes or your topics on direct proportion. All right. So again, this is now some sort of a differential equation. So to solve this one, we just have to manipulate it by means of algebra. So we can do a manipulation, thus we will get this. And then once they are already appropriate, a with the dA, k is just a constant, so it could be with dt. So we can now do integration. Thus we get ln of a equal to kt plus c. All right. Now, again, if you wanted to solve for the a, so we have to raise an exponent. We have to raise e with exponent ln a. Ln a has a base. Ln a means logarithm of a to the base e. Therefore, to solve for a, you need to make it an exponent to e. Okay? And whatever we do to the left, we do to the right. Hence, uh, just to make it also simplified, so you have seen before that the one at the right is simply we can apply reverse product rule. So eventually you will get here an e power of c. So in this case, I will assume or I will equate e power of c with just one variable, capital P, to make it more simplified. So a is equal to p, which is the e power of c, times e raised to kt. So when a is equal to, we're given that in order for us to find the value of p so that we can somehow come up with a specific function, so we need to find something given by which this, because here we have a lot of variables. We have p and we have k. So for us to solve for p, this must be set to 0. So that what's left would just be simply p, and so we can solve for the value of p. So that's our focus now. We wanted to find a specific function, so we need to shed light. We need to have a value of p and a value of k. First, let's try to find a value of p. Now, for us to find a value of p, we must eliminate this particular variable k, because if there are two variables, it's difficult to solve. It's difficult to find the value of the other. So we need to find the value of this k first. So if you try to look at the given, we are given that initially the amount is 2 centimeters squared. Therefore, we can say that when t is 0, a is 2. Okay, that's our first value then. So in this case, we can now substitute your a with 2, t 0, and by doing this, the entire exponent becomes 0, leaving us with p. Therefore, p I think this is p is equal to 2, not e. So this is now p. Wait, let me just clarify this one. So this would now be 2 is equal to p times e power of 0, by which it gives us 2 is equal to p times 1. Therefore, p is equal to 2. Okay? So your p here then is equal to 2, not equal to e. Now, having had this, having the value of this already, we can now proceed. A is equal to 2, which is the value of p, times e raised to kt. This time, we have to find the value of k to give or to get a specific function. Now, to find the value of k, we are given that a is equal to 9 when t is equal to, that's the second one, right? So if you recall your direct proportional word problems before, to find the value of k, we need to find, or we need a value of the two quantities, and we are actually given 9 and 2. So pause the video and copy the ones that I have annotated because I'll be erasing it. Okay. Okay. So we now have 9 is equal to 2 times e power of 2k. So we can now divide both sides by 2. So we'll have this function, this function. And then to solve this one, remember that's e power of 2k equal to 9 over 2. We can actually we can convert this into its equivalent logarithmic function with the base e. So we now have logarithm of 9 over 2, the logarithm of 9 over 2, 9 over 2 being the value, to the base e, and this is equal to 2k. So when you do logarithms, the answer is the exponent. That's the answer to the logarithm. So we now have here logarithm of okay. So we can write this is another way of doing it. We could also write this as logarithm of 9 over 2 to the base e equal to 2k. This is 2k. All right. Now, having said this logarithm to the base e, you'll just simply ln 9 over 2, and you now have equal to 2k. Okay. Now, the one I'm doing here is actually a shortcut. If you wanted to solve this easily, if you have e power of 2k, now to eliminate um, this easily, you can just find the logarithm, the natural logarithm, both sides, so that you will simply have a 2k. Okay, this is to easily eliminate the e here because 2k here is your exponent. The one I'm showing at the right is the entire process. So converting this into a logarithm, you will have a logarithm of 9 over 2, which is the value, to the base e equal to the exponent. This is this is the basic idea of what logarithm is. And logarithm of base e is ln. So ln 9 over 2 is equal to 2k. So if you try to look at it, it will give us the same answer. So ln, okay, that gives us 2k equal to ln of 9 over 2. So they're just the same if you try to look at it. Thus, we can now solve for k here by finding the logarithm of 9 over 2 divided by 2. And therefore, k is equal to 0.752. So again, here you need to review your logarithmic rules and properties. Okay. Since we now have the k, we can now come up with a specific function. Remember, pause this video first and copy down notes. Remember that we have here a equal to 2 times e raised to the power of k. Raised to the power of k. Now take note, we already have found the value of k, which is 0.752. Therefore, we now have this one. A equal to 2e raised to the power of 0.752t, or the time. Now, we are ready to solve for b, because for b, we are just being asked of the value of time by which it will cover, or the mole will cover 20 centimeters squared. So we just have to substitute 20 and solve for time. So from here, we can now find ln of 10 and ln of e. So you have two ways to do this. So what I'm doing here is using or converting this into a logarithm. So ln, this one raised to this exponent equal to 10 is just the same as the logarithm of 10, the value, to the base e equals the exponent. And that's what I'm doing here. Now, if you try to do or apply the one we had a while ago, you can just simply get the logarithm both sides, Thus, you will get 0.752t equal to ln 10, which is just the same as this. Again, review your laws of logarithm. So to solve for t, divide both sides by 0.752, thus t is equal to 0.361 days. Okay? So this will be our focus this coming Monday. And I'd like you to answer a few of 11L so that when you go to school, you will only ask me questions about those items you're not able to answer. I will be checking your notes to see if you are doing this one.